Before we dive in, let's do some introductions. Lee, would you like to introduce yourself?
Yeah, my name is Lita Cho. I work on the networking team. I work on specifically managing our front proxy and our service mesh, which all runs on Envoy.
And I've been at Lyft for a few years, and I've been on a number of different infra-related teams. I currently lead a team that works on resilience engineering. And you might have seen some of my teams work in the open source Envoy repos these days with the adaptive concurrency work that's going on in there. And so if you're interested in chatting about that, I can hang out later and discuss that. But let's frame the talk a little bit. So this is not introduction to service mesh. By now at KubeCon, you've probably had a dozen of those already. What we're going to do today is look at what to do when your control plane or your data plane is not behaving in a way that you expected. So this could be during dev and test, or it could be a production incident. Basically, how to tease further information out of Envoy itself. And we're not going to get into specifics of app mesh or Istio or other control planes, but I believe that most of what we will convey is usable for any control plane that uses Envoy. So this is a talk in 3 parts. We will first start with a consideration of config. Config can be a very complex thing in Envoy. You might get config from a bootstrap file and from 3 other servers that combines itself into a single Envoy instance. And so reasoning about the origin and the provenance of that config data can be a complex thing. We'll talk about some tips for that. Lita will present that section. Then I'll do a deep dive into logs, specifically access logs in Envoy, ingress, egress, all types of logs. And then we'll wrap up with a look at stats. So Lita, you want to start us off with config?
Yeah, sounds good. Let's get started. So again, this is specific to Envoy configuration. And I thought we should start off with a high-level picture. So Envoy have 2 types of configuration. One is the bootstrap file. That's a static configuration that lives in either your VM or your container. And Envoy will read that and then start up and will use that configuration for the life cycle of Envoy running. However, managing a bunch of those bootstrap files is cumbersome, and so Envoy also has dynamic configuration known as the XDS APIs or star DS APIs. And basically, that connects to a control plane that sends dynamic configuration while Envoy is running. So there's no need to hot restart or restart Envoy. You could, on the fly, send configuration to Envoy directly and then have quick deployments and rollbacks as well. And so when you're debugging, you kind of need to figure out, like, what is the main issue? Is it a XDS problem, or is it a problem with my bootstrap file? And some tips I have at a high level is that usually startup issues, especially if they're global, tend to be due to malformed configuration. Envoys will be verbose if there's malformed configuration given it to it. And also, but however, with if there's an issue with your dynamic configuration, Envoy keeps the last well-known config. So you won't, if you don't have the proper observability in place, you may not notice until Envoy scales up, which is also not a good situation to be in. So what are our tools at our disposal? So the tools I use to debug configuration issues is config dump, which is an admin endpoint that you still have to set up in your Envoy proxy, but it's an interface where you can curl, and it will show you exactly what Envoy is running at runtime, both static and dynamic. So it's very useful. You have to set up the admin interface. At Lyft, we set it up such that there's a local host, so you have to have privileged access to curl this endpoint, but then you can see all this data once you're in the box. The other ways I've seen people set this up is they have like a firewall or a secure network to curl this information from the VM or container directly. The second thing that you could leverage is trace level logging. This is super useful, especially if you're trying to set up something new in Envoy. So let's say you're setting up a new XDS API or a new feature. Chances are you're not going to get that right the first time. And looking at the trace level logging will tell you exactly what's going on and where the problem is arising. So, and oftentimes, if you're doing a bug report, the maintainers or the community will ask you to post a trace level logging along with your issue. And so this is the way you go about it. Either you can turn it on dynamically but via curling the admin endpoint, or do a command line argument on startup and set -l trace, and that will give you all the trace level logging when you're starting up Envoy. Okay, so let's go into like a realistic scenario. A healthy Envoy, when it starts up, usually ends with this log line, which is all dependencies are initialized, starting workers. So that means Envoy is now able to take traffic, and the workers are the request workers. So that's like the happy path and what you're looking for when you're looking at the logs. These logs are not the access logs that Ryan will go into later in the talk. These logs are the server logs that Envoy emits in the main thread. But now you're seeing this. You're seeing like an issue with some sort of config, like it makes a GRPC stream call and like realizes there's no healthy upstream. And let's say you're trying to set up your control plane. This is the first time you're setting it up, and you're seeing this error. And Envoy hangs, emits this log line a couple of times and restarts, and it keeps going to this loop. So what do? This log is not enough to kind of figure out what's going on. So let's just try running Envoy with trace level logging. And so I concatenated a lot of the data here, like the timestamps and the code line where this log is emitted, just so it'll fit in the screen. But it gives you a lot of information. Like it gives you debug logs as well as trace level logs. And we see that warning again, so that gives us a form of reference. But ultimately, oh, look, our DNS was not set up correctly. And note that that was like stated in the debug line. But what was happening was that there's no healthy upstream because that DNS didn't resolve to IP addresses, and so it was not able to talk to the config server. But then again, we were able to get, we were able to get more data through these traces to see what's going on. So let's go to a different scenario. This one affects real users. Let's say you're actually running Envoy in production, and in this case, there's an edge proxy that your customers go through before reaching the application. And you notice that, oh, certain users are getting 404s, and you get a customer report about it. So the application dev goes in and tries to triage this issue, and when she debugs the endpoint, and let's say this application is stateless, she gets a 200. She cannot repeat this 404 or reproduce this error whatsoever. So now she's confused and goes to the networking team, it must be a networking issue, goes to the front proxy, and so now it's your job to figure out what's going on. So what's on our tool belt? What can we do to figure out what's happening here? So let's look at config up. So when you curl this endpoint in Envoy, there's going to be a lot of configuration here. But it helps to kind of look at the high level to see what shows up. So you have your bootstrap configuration, you have your cluster and listener and routes. And if you have secret discovery set up, that will also show up here. And so that's a good thing to note. You should separate by type and then try to pick out where to dig into. Note here also, again, it shows you both static as well as dynamic configuration. Everything that's dynamic will have a version info with it. And that version is set by the control plane. And if you have any issues with your config not updating or your XCS not updates getting rejected, that version info will not match with your control plane. And that's also another signal that something's not working right in your system. So when I think of 404s, it usually has to do with routes. So the route table is misconfigured in some way. And let's say you looked into the Envoy access logs, which Ryan will go into later, and you're using an NR, which is an Envoy specific response. And Ryan will go over all the response flags later in the talk, but NR stands for no route. It means that Envoy returned a 404, not the application, meaning that there was no route table that it could find, or it couldn't find a route to match the traffic with. And so let's dig into the route table and see what's going on. So you look at, aggregate all the route table or the dynamic route configs from all your hosts, and you notice that the old ones don't have, the old ones have the route table properly, but the new ones don't. So what does that mean? So again, when I mentioned earlier in the talk, Envoy keeps the last well-known config. That's how it stays resilient to bad configuration changes in XDS. And so then when the new boxes don't have a good known config to go off of, Envoy's still going to run, but it's not, and take traffic, but it won't route. It has no routing information to send that traffic to. So you know that there's something wrong with your XDS configuration. So knowing that there is an issue with configuration, you could see that looking at the server logs, it states clearly now why it got rejected. So there's a duplicate entry, and that's why it rejected the update. And thus you know to roll back your bad XDS change, and then you'll be able to serve your customers' traffic. Note here that there's also stats that you could alarm on this. And so as long as you have the proper observability, you shouldn't get to this state. But also note that Envoy will tell you exactly why it rejected also to help root cause your issues. And the other thing I wanted to mention on the side is that if you decide to statically define your route table in your Bootstrap file, that would be a critical error, and Envoy won't start. But however, if you use XDS, it will run, but it will end up just rejecting the update. So some quick config takeaways before we move on to logging. The main tools that I leverage is the config dump as well as trace level logging, and they will show you both static, and config dump will show you both static and dynamic level configuration, which Envoy is running at runtime. Trace logs, and then the other thing I wanted to mention is that dynamic configuration, Envoy will use the last well-known good config. That's how Envoy stays resilient. And so you won't see any dynamic config issues on scale-up unless you have the proper observability in place. And then also, trace-level logging is very useful, especially if you're enabling a new feature or if you want to dig into what's going on. It gives you a lot of data. I didn't go too deep into it, but it will show you the XCS payloads. It will show you the headers that are being sent in the data plane. So, and also the bytes information if you want. So, so definitely use that to your advantage, but note that it's very verbose. So you could also customize the level of tracing to this component of where you care about, whether that's the upstream section, the config area, or the HTTP connection manager. You could enable tracing for those specific components. Okay, and then Ryan's going to take it off with logs.
So to motivate this section, just a very small toy example here. You might imagine that you have a simple app that is a weather app. It calls into some edge proxy that transits to a sidecar. The service performs some weather forecasting or data collection. And as part of that, it calls out to some external APIs to get data. So I guess this is an interplanetary weather app. It calls out and it gets the weather on Mars here. But you've got some problems with this third-party call, and you want to know what's going on in each of those calls. And so you want to know a lot of details about that. And so we're going to use Envoy logs to do that. And so in this section, number one, we're going to look at how to configure a log for traffic that's exiting the mesh. So the point I want to just kind of make here super explicitly is you'll notice there's no arrow from this service directly to the API. There's only basically a line that goes from the service to Envoy and then out to this third party. So this is known as using Envoy for egressing your external traffic. Sometimes people call this, I believe, a forward proxy, to proxy traffic outside of your system data center. So we'll look at how to set that up and what some benefits are. We'll dive into the filtering capabilities of access logs. You can build super sophisticated and potentially very complex logging rules. And then we'll look at an alternative to using file-based logs, which is known as the access log service, which is a mechanism by which you can send log events over GRPC. So how to set up Envoy for egressing traffic to a third party? This is generally done by setting up a dedicated listener. And so you might have some listeners associated with traffic coming in and out of your service mesh. And in this example, what we're saying is we're going to allocate port 7001 to all traffic going to this external service. And so the code that is actually reaching out to this API it won't use that URL explicitly. It will call into localhost port 7001. It will specify a host header of api.nasa.gov, and then Envoy will route that traffic out. So what are some benefits of doing this? Big benefit is that you get all the stats. You get all the same stats you would if you're using Envoy at the edge or if you're using Envoy in the mesh, and you get it in this sort of very nice unified format. Further, you get the explicit retry policies of Envoy, so you can tweak the retry policy, have it handle that on your behalf. If you want to use rate limiting, that's possible as well. There's really a bunch of benefits. It'll do connection warming, out-of-band DNS resolution, and the list goes on and on. But for our example, critically, it gives us the ability to specify a log file for this traffic. Sorry about the YAML. Wouldn't be a KubeCon talk without pages of YAML. In fact, I asked for feedback on my slides, and Lita told me I just needed more Taylor Swift. I don't have that. All I have is YAML for you. Sorry. So this page of YAML defines a listener. And this is the exact type of config you would do if you were trying to set up this type of egress. And so you can see, bind this local host, dedicate port 7001, listen on that. If you look down to the bottom, you see the route is basically saying send everything to api.nasa.gov. And then here's the access log specifier. So even if you've never seen one of these before, you can probably guess what's going on. This is kind of like a printf style format string here. If you Google Envoy access log, it will land you on a really excellent page of the documentation that outlines what each of these fields are, all the possibilities that you could include in your own custom format strings. So you can do a lot of things in here. You can specify fields related to gRPC, for example. You could extract headers that are very specific to your environment and your infrastructure, and you can include those here to maximize the benefit of this. So that gets you the log file, that gets you lots of visibility into this data that's egressing your service. But maybe you realize you've just got too much data now, and you need to slim it down. So enter the filter section. So the filter section of the config allows you to specify one of a handful of very powerful filters for your access logs. So in this case, we're saying the numerator is 1, denominator is 100, so sample effectively 1% of traffic going out and send that to this file-based log. You might notice that runtime key below. That gives you an interesting capability here, which is to turn these knobs live at runtime without reloading Envoy. So you might, for example, have a default state of a very low sample percentage, and during an incident, you may want to crank this up. And so you could specify a higher sample percentage in real time to get more fidelity out of your logging system. Different scenario. Maybe you want to log only errors for external traffic. So don't care about the 200s, don't care about the redirects. You want to know about the 404s, the 503s, all that sort of thing. So the first thing you might see here is at the top, we've got a predicate filter. So there are, I believe, 2 of these that are supported by Envoy and an OR. And so in this case, we have the OR filter specified by a list of other filters sort of nested underneath. The first of which is the status code filter. It basically says, look at the status code, look at the operand, and if it's greater than or equal to, in this case, log it. It ORs that with the output of the other filter. This is the response flag filter. I actually didn't really get into that as much as I wanted to back here. I did circle this. You might notice that response flags in the access log format. In fact, if you get really one thing from this talk and you're not familiar with the response flags, it's well worth your time just spending a little bit of time studying what these response flags are. So the canonical example is that Lita alluded to earlier. You hit an endpoint and you get 404. The natural question is, was this Envoy that gave me the 404, or was this the remote service that gave me the 404? And so if all you have is response code, there's really no way of reasoning or disambiguating these things. But if you have that response code, you can look at that and you can reference it with the codes that are documented in Envoy and understand precisely who was responsible for returning that code. And there's a really rich set of data in there that can accelerate your triage capabilities. So back to logging external traffic. So this does a greater than or equal to on the operand. If it's 400, it will return it. Or if Envoy has set that response flag at all, if it's set any flag there, it will also return a true here. So basically, the 2 of these put together will give you every error in that egressing traffic. What if you want to log slow calls, and in this case, we'll say to an authenticated external service? This is somewhat contrived, but I think it shows the power of the filter capabilities very clearly. Again, we've got a predicate filter, and the first filter that we're hitting is a header filter. So it says, look at egressing traffic. Does it contain an authorization header. If it does, and the duration of that request is greater than or equal to 2,000 milliseconds, then log it. So you can probably start to see with file-based logging, with these filters, how you might be able to compose some really sophisticated and powerful logging mechanisms within your own infrastructure. But simultaneously, you're probably also painfully aware of the limits of file-based logging, particularly if you're deployed in an environment like Kubernetes, where maybe you want to keep read-only file systems, or if you're doing something fancy, like with all these filters and multiple access logs, maybe you have like 5 logs, and your logging system really wants everything on standard out, standard error. What if you wanted to avoid file-based logging altogether? So Envoy provides this mechanism known as the access log service, and it's illustrated here in blue. So the general idea is open source Envoy defines an endpoint in the open source repo. So there's this proto definition there, and then you as a customer, you implement that GRPC endpoint. That's what the blue box is. And then you point your envoys to that service. And then it streams via GRPC, very low latency, all the log events to that service, and then you choose what to do with it from there. So this is kind of a glue, probably like a stateless glue service that basically grabs this, unpacks it, and then hands it off to some other internal system. Maybe it's Elastic, or maybe you treat it more like a streaming data platform problem. We do this at Lyft, and I've been working on this actually over the last couple of months with some teams. And a few observations from that is recasting this like file logging problem into more of a streaming data platform problem. It lets you think a little more clearly about what you're trying to do. You get all this type safety and extensibility, but you also get to leverage your existing systems. So like we run Flink jobs over these event streams in real time. These events find themselves into Druid, so we get near real-time access to these events via a SQL interface. They find their way to Hive, so we can query via Presto, for example, large sets of this data. And different teams have found this to be enormously valuable, and it's allowed them to combine these data sources with other data sources for like much more powerful use cases. So it sounds a little bit complicated, but it's actually pretty straightforward. So this is what a config looks like if you're pointing an Envoy at an access log service implementation. So instead of saying file access log, you say HTTP GRP access log, and then you give it a cluster name. That's a cluster name specified like any other cluster in Envoy. And that's all there is to it. You'll notice the filter section is there available too, so you can compose those same filter capabilities together to give you non-file-based access logging with super sophisticated filtering capabilities. What about the other side of it? So what if you're implementing that blue box, that access log service? If you've never done it before, it might sound sort of daunting. How do I implement a gRPC endpoint? Well, it turns out there's help. Within the Envoy repo, there's this thing called the Go control plane. It's kind of like you could think of it like a Lego set for composing your own control plane. And so there's an example of an access log service implementation in that repo, and I've just taken this directly from there. So you can see really with just like half a page of code is the meat of the implementation. This one method, you can see what it does. You can follow it even if you don't know Go code. Basically loop forever, go pull messages off this stream, look at the message type, and then at the bottom, you've got full access to this structured, very, very rich logging event data. And when I say rich, it's extremely rich. There's all these like, very sophisticated timings in there, time to first byte, time to last byte, upstream, downstream, tons of super useful things in there. I did kind of skip past this too, but on the configuration side, there's these optional fields where it's like as these events are coming through, you can choose to extract request or response headers and include those in this event prior to it being dispatched off to that service. So again, maybe you have some headers that are super specific to your environment, but very vital, maybe identify users or sessions or that sort of thing. You can pull them out of here, put them in the response, and then forward that along and have full access to that in the pipeline. So that's config, that's the implementation, not actually that much to it. So some takeaways. If you want to use file-based logging, it's highly configurable. You can specify the format to your liking. Very flexible, composable filtering mechanism for access logs. As you saw, we can combine these with various predicate logic to get really sophisticated use cases realized. And then if you want to avoid file-based logging entirely, you can use this access log service. It gives you typed, low latency mechanisms for doing pretty fancy things. In terms of the future, I think there's some interesting potentials here, and specifically, one of them that I think my team's going to do some work on in the coming year is this notion of like dynamic fidelity. So maybe you have your logging turned way down or almost off, but dynamically at runtime, you can have a knob to basically throttle that up and change the throughput and change the richness of that logging data that's coming through to get really precise information about very specific aspects of your service mesh. Another thing that occurred to me actually while I was working on this talk is I think there's some interesting opportunities for collaboration in open source on a reusable access log server implementation. So I think you don't have to squint too hard to picture an open source project that basically is a sink for these events. It grabs it in via GRPC, performs perhaps some sort of optional transformation on it, and then has a pluggable backend. Maybe you have a Kinesis backend, a Kafka backend, some other pub sub, some Elastic backend. That could be very broadly usable, I think, across a lot of companies. So that's logs. The final section is stats. Back to you, Lita.
Thanks. So actually, stats are one of my favorite things about Envoy, and so and there's a lot of them, and so we'll crack a little bit about how to go about navigating the world of stats, particularly in Envoy. So I decided to try to figure out a taxonomy of stats, if that was possible. If you curl that admin endpoint /stats, you're just overwhelmed with the amount of data. And that's been my learning curve, is how do I think about what stats I care about, where should I be looking if I'm having networking issues, or if I'm trying to debug, or I'm trying to roll out a new Envoy feature. So this is what I came up with. With the help of the docs and just thinking about it a lot, but I've organized them to downstream stats, so these are your listener stats. So if you have any issues with TLS or codec problems, or specifically with requests coming into your proxy, you will be probably looking in your downstream stats. And then there's the upstream stats, and then the control plane stats, which are, I'm not going to go too deeply into, but I do leverage these a lot, specifically around if an update was rejected or if a configuration was misconfigured, I will be looking in there. And then your Envoy internal. So let's go into each one of these little sections. So downstream stats, again, these are requests coming into the proxy. These are your listener stats. When you're trying to set up TLS or you have neutral TLS, you'll be looking at the TLS inspector and seeing is my cert, am I responding to the traffic correctly? Am I getting, what are the certificates I'm getting? So those are the things where these stats would be helpful here when you're wanting to inspect the traffic coming into your proxy. The second is the cluster stats. So these are the stats actually I use the most. These stats are emitted when Envoy is the client and sending off to either your third-party API or to another service. This is where your load balancer stats will live. This is where your health checking will live and service discovery will live. Again, the stats are, you care most about, for me, I care most about what the client is seeing, because at the end of the day, that's that's the most important. So I usually check the view of 5xx, 4xx from the cluster perspective, which is I equate it to the client perspective. And the process stats, this is the actual server itself or the process of Envoy itself. So I get a lot of questions around is Envoy performant? Well, how much memory does it take? How much CPU utilization does this take? Envoy emits those stats. Envoy has stats around memory usage, and if you're using Envoy's hot restart functionality, this is where the stat will live. It will show you the amount of connections in the parent process as well as the child process to ensure that the hot restart is working as properly. But also, this would be good to monitor along with if you're using, if you have container stats or your VM stats, it would be good to see, compare those to see, do they match up? Is something funky going on if they're not matching up? And so that's extremely useful that Envoy emits those. So I decided to go into some of my useful stats that I decided to share with you. Most of these are cluster stats. So the upstream request pending total and upstream request pending active. So if usually in a happy path, the active should match the total. Whenever the total is not matching, and the total's request pending total is a lot greater than request pending active, that means Envoy's request queue is backed up and either your application is not responding quickly enough to your requests, So there's a load issue there. Or maybe you misconfigured how much active requests your system can take, so that maybe there's you need to reconfigure. There's an Envoy configuration you need to update. But usually, like monitoring those when you're triaging issues, these are the stats I'm looking at to ensure that your system is humming along properly, or if is it backing up and can lead to cascading failure. The other stats I look at is service discovery. This health checking is a very important aspect of my job. So I look at both health check. We use active health checking as well as passive health checking, which is outlier detection. So I tend to look at that. I also look at membership stats. So that's how many healthy hosts there are. And ideally, membership total should match membership healthy. And also panic routing. So like, that's Envoy's loud way of saying your mesh is not converging. And so we page on this if this is ever happening. But ultimately, there's a lot. If you, again, like I wanted to put a list of all the stats Envoy emitted, but it didn't fit on the slide. So, and I don't think that's the experience you should give to your end users, which is your application developers. So at Lyft, we provide a dashboard to make the network understandable and transparent. So here's a service dashboard where a service owner can see like what are the network requests coming in and what are network requests I'm emitting out, like what service, and we show what services you're talking to as well as what services are talking to me if we have that data. We also look at retry counts as well, and this dashboard doesn't show it, but we have timeouts as well. So this is at the end of the day, like I think most people do this, most companies do this, where we try to convert all these useful stats and distill it down to a dashboard that's easy to understand. And then if we're triaging or trying to root cause an issue, we make custom incident dashboards to see like what's going on and try to figure out root cause issues. So the key takeaways of the stats is that I try to organize the stats as a taxonomy to figure out what am I trying to solve, what question I'm trying to answer, and then use that to leverage where to look, because there's a lot of stats in Envoy. And again, yeah, Envoy emits a lot of stats, and you could do a lot of root cause analysis just purely on stats, which is pretty amazing. But again, like it requires you to figure out what question, like, am I worried about, like, did TLS break? Was it, am I getting a bunch of 500s? Is my request queue backing up and my application's not responding quickly? So trying to figure out what question you're trying to answer, and then organizing the stats of downstream, upstream, and then the process stats will help. And then at the end of the day, it's worth making a dashboard for your end users so that they could also monitor the network in an understandable way. There's too many stats for one person, like for every engineer to understand. So distilling it down to like something that your company can monitor the health of their system would be useful. It's been useful to us at Lyft. And that's it. Thank you so much for coming to our talk.
Thanks so much.